Hi there, Turgeon here, bringing you physics from afar. Whole idea here is I'm going to prepare you for this MCAS exam. If you listen, take advantage. Your teacher's coaching you, telling you all the answers. Learn from this. Write things down. When you write things, when you rewrite things, that's a way of learning. You could ask questions, write those down too. Remember, you're here to think, you're here to listen, and not just I'm going to get the answers from the teacher. You're here to think, I got to learn this stuff. There's a lot of skills involved in the MCAS. It's not just physics knowledge. It's using the equation sheet. It's using logic, and it's reading carefully and not being intimidated. Here's what I mean by the equation sheet. So remember, think and write. Let's go. Here come the answers to 1 through 10. Don't be intimidated. Read it over a few times. If you look at this equation sheet, you'll see that there's this equation for efficiency right here. Yeah, it doesn't, honestly, I got to tell you, it doesn't help very much on this question because you're not using energy out over energy in. Let's think about what efficiency is. And again, this is one of those topics that the teachers, it was not made clear to us by the state of Massachusetts how much we should emphasize efficiency. So here we go. Let's do our best by reading this problem. But it's asking if you take electrical energy, turn it into mechanical. So this is the energy in, this is the energy out. This is the useful stuff. The energy out is the useful stuff. But what they really want you to think about is the wasted energy, and that wasted energy is thermal energy. So there's only one choice in which you're going to maximize the useful, minimize the wasteful stuff. By the way, the efficiency of a car engine is only about 30%. So what did we learn about efficiency? We learned you want to get the most energy out for the energy you put in, and you want to minimize waste. Number 2. These great comparison between these two questions. You can see that we have a similarity where the distance gets squared and the distance get divided. That's an inversely proportional relationship. You can see that these quantities Q and M, and at this point you're taking the test, and if you start to get confused, just take a deep breath. It's really not a big deal. Everything's told to you right here. Oh, Q is charge, M is mass. No big deal. So we can see here you have a little bit of knowledge of gravitation. You know that gravitation only pulls. Only pulls. So it says the force can be repulsive. See that? All right, so we know that can't be Newton's law because repulsive means to push away. So that eliminates choices B and C. Okay, so what about the force can be attractive? Yeah, they can both be attractive. Remember, if you have two charges, like the two fists represent the two charges, then those charges could attract if they're opposite charges, and they can repel, they can push away if they are like charges, meaning like you got two negatives or two positives here. So that's both laws, attractive, and gravity is always attractive. What about if the mass increases? Look at the equation, guys. Look at this. It's right there. It's saying to you, oh, look, mass. This doesn't even have mass in the equation. So clearly, that's only Newton's law of gravitation. What about, does the force decrease if you make them farther apart, if you increase the distance? Yeah, because if you divide by this number, then you get a smaller quantity. Therefore, the answer choice is clear. We can eliminate this one, which says only Coulomb's law. That's not true. It's true for both. Moving on to number 3. When you see a circuit like this with a bunch of resistors in it, you should be thinking, is this a series circuit or is this a parallel circuit? Series would mean there's a bunch of resistors in one path all together, one line. We can see here that there's multiple loops. Student wants a lot of current to pass through here. Okay, we want to get a lot of current going. So you want to get the minimum resistance. Path of least resistance. When you look at this, you should just think these are really 4 ohms. Remember, ohms are for resistors. You should think these are really 6 ohms. So each of these loops, each of these branches, and by the way, the distance does not matter. It doesn't matter how far away they are from the source. And you could take the 7 and replace it with the 1 and the 3. You could switch W and Z. You could replace these with each other and it would make no difference in this circuit. It doesn't matter how far away you are, all that matters is the connection. So we want to minimize this. We want to minimize the resistance. So the choices are W and X because you have less resistance going through here, which is going to bring more current back through the whole circuit. And by the way, close means to allow current. It's like closing a door. It creates continuity from the wall through the door to the other wall. Close means allow current. Number 4, use the equation sheet. It says you've got these different energies that we're going to calculate. So just take a deep breath and think, all right, I want to calculate potential energy or kinetic energy. And you look up here, there's the equations. Now the thing is, the information they give you is mass, height. I mean, mass and height, you can only calculate potential energy. So let's use MGH. Same as you have often seen it in class without the deltas. And just plug in 2 for the mass, 10 for G, 1 for the height. Let's remember, G is always 10. See that here? Yeah, you're getting ready for this MCAS. This is not too bad. So the gravitational potential energy, you calculate, you get 20 joules right there, and 0 kinetic because it says it's released. Okay, so it could be this one or it could be this one. Okay, so we know we have 20 joules. Then it says, what about ABC? All right, so we know we want that 20 joules. That's going to be conserved. That's going to stay the same because of law of conservation of energy. If you look at this one down here, 20 total, 25 total, 20 total. That doesn't make sense. You can't suddenly get no energy. So obviously we need the mechanical energy to stay at 20 joules the whole time. Your answer choice is clear. Number 5, negatively charged particle coming through here, going to be repelled by the top and attracted to the bottom. Both of those, repelled by the top, pushes it down. Attracted to the bottom, pulls it down. Remember, this is a negatively charged particle. Okay, answer choice is clear. Number 6, use the equation. How do you know? Well, it says net force and there's no diagram, so let's use F net equals ma. It's right there, right there. And then, oh no, I don't know what to do. Well, it tells me 5 kilograms. All right, that is a mass. And it tells me the acceleration. It's 2. 5 times 2 is 10. Then it asks me, what if we increase the mass? Well, if you increase the mass, you can tell just by looking at this equation that if you increase this mass but you keep that the same, then the acceleration has to decrease. Here's something we learned toward the end. Again, this is one of those things that the state of Massachusetts didn't make it clear how much we need to know. But light has many ways in which it behaves like a wave. For example, we saw light reflect off the surface of water. We saw it refract into the water. Those are wave behaviors. One thing, though, is like the photoelectric effect, as you would see in a solar panel. The light knocks electrons out. Knocked. That's a particle momentum thing. So this one is describing waves, and observation 2 is describing particles. So there's your answer. Think about it. Rewind this at any time. Rewind this if you need to for these hints. Whenever you see, number 8, whenever you see specific heat, mass, and they're talking about how much heat flowed, in or out, I mean, come on, you're going to use this equation. There it is, equation sheet. Q equals mc delta T. Sorry about the scratches. M is mass. C is not Celsius, remember? We're reviewing. C is not Celsius. C is specific heat. Don't freak out about this being grams because this is also grams, so you don't have to convert anything. Q equals mc delta T. mc delta T. Yeah, be careful. Delta T means the change in the temperature from 50 to 20. That's a change of 30. You might say to yourself, that's a negative 30. Sure. You just think of these as all negative numbers because it's heat lost. Okay, so I can see the biggest number is 144 and the smallest number is 96, and your answer choice becomes clear. You just got to remember least to greatest. Number 9, please tell me this was an easy one. If it's not, that's okay. If you add all these up, it looks like 24 plus 13, but no, the 12s cancel out. The 10 and the 13 are in opposite directions, so they kind of cancel out. You're going to do 10 minus 3, which is the other way to get net force, which is from a diagram. Answer choice is clear. Number 10, Another miscellaneous topic, state of Massachusetts, unclear, and it's a new thing in our curriculum. Fission means to split. Fusion means to fuse, or to put together, or to combine. Anytime anything undergoes fission or fusion or decay, it's usually going to release energy. This is a splitting up, so that's going to be the one that's not fusing. And this one's asking about energy. All right, so remember this. Thermal energy is kinetic energy of molecules. These molecules are going faster. They have more kinetic energy. They have more thermal energy. This is how a nuclear power plant works. So remember, watch this again if you need to. Listening, writing, reviewing, because we're building some physics skills. Look for the next video. This has been Turgeon bringing you physics from afar.